Alright guys, so in this video, I'm going to talk to you about how do you do integration by parts using a definite integral. So you're going to start with the same formula from before for the ultraviolet voodoo, so u dv equals uv minus integral v du. But now, here's the thing. Now we have bounds, we're going from a to b. You're also going to go from a to b on this integral. But the other thing is, you're going to also plug in a and b on the ultraviolet, like you'd already done the integral. So you're going to plug in b and a, and then subtract, just like you would normally do if you've completed just a regular integration by parts integral. Okay, so let's look at a couple examples of where you'll see problems like this. One with just a regular equation, and then one with a table. So let's say we have to do integral 1 to e of x squared ln of x dx. Now I think it's pretty clear looking at this, like it's not a u sub. We see two things multiplied. Let's try integration by parts. Natural log x is always a good choice to pick for your u because it goes away. You might try and do, u equals x squared, because that's what you normally do in these problems. It's x squared times sine, x squared times cosine, or e or something. It doesn't work that well here. But let's try ln, because we know if we take the derivative, it'll just go away. And we know that if we have dv equals x squared, that's not too hard to integrate. That'll just integrate to be x cubed divided by 3. Okay, so let's go ahead and set this up. So we know that this is going to be uv going from 1 to e minus integral v du going from 1 to e. So this is just going to become, okay, so x cubed over 3 times ln of x going from 1 to e minus integral from 1 to e of v du. So that's x cubed over 3 times 1 over x dx. Now, let's go ahead and clean this up a little bit. This is just going to become x cubed over x is just x squared over 3 dx, going from 1 to e. And then, okay, and here let's just write it the same, I guess, for now. Okay, so again, what you're going to do is you're going to plug in just like it's already been integrated, in a sense. So when you plug in the e, you get e cubed over 3 times the natural log of e, just 1, minus 1/3 ln of 1. Go ahead, Cassie, can you take that out of the oven, please? Sorry about that. So anyway, when we do this, the natural log of 1 is 0, 1, this is 0. So this just becomes e cubed over 3 minus 0. When I do this integral, this is x cubed over 9, or x cubed over 3 times a third, going from 1 to e. So when I plug that in, be careful with parentheses. So when I plug in the e, that's e cubed over 9 minus 1/9. Okay, so that'll just become e cubed over 3 minus e cubed over 9. Be careful again here, plus 1/9. Okay, and that's fine. You don't need to like simplify at all, obviously. So that's an example of definite integral with an integration by parts. So let's take a look at another example, and this will be our last one in this video. I'm going to give you a little table here. So we have x, we have g, f, f prime, and f double prime. Okay, and the x values I'll give you are 1 and 4, and here it just goes 1, 2, 3, 4, oops, and then 7, 0, 6, 2. And I'm going to say this. I'm going to tell you, if you know that g prime of x equals 2 for all x, and then I'm going to ask you to find the integral from 1 to 4 of f double prime of x times g of x dx. Now, when you are blessed with a problem like this, you should look at this and first off say, well, okay, obviously I know how to, or I should be able to solve this problem because they didn't give it to me if it's impossible. Okay, I see two things multiplied together. So if I see a product, that tells me that I'm going to use parts for a strategy. So I'll set up my u, I'll set up my dv. Now, which of these is easier to integrate? Which is easier to take a derivative? Well, I mean, g, I don't know how to integrate g, so I should pick that to be my u. And then for what I integrate, well, I could just integrate f double prime, because the fundamental theorem means, oh great, if I were to integrate that, if I integrate dv, if I integrate f double prime, I'm just going to get f prime of x. Sweet. Not dx, sorry. And if I take the derivative of g, the derivative of that is just g prime of x dx. Okay, so let's set up the parts. So when I'm setting up my parts, I know this is going to be uv minus integral v du. And I'm going from 1 to 4. So what's u times v? So that's g of x times f prime of x going from 1 to 4 minus integral v du. So minus integral f prime of x times g prime of x going from 1 to 4. Okay, Now, the first part of this is pretty easy, right? We're just going to plug in. So this is just g of 4 times f prime of 4 minus g of 1 times f prime of 1. And of course, we could just get those values, right? G of 4, they told me, is 7. F prime of 4 is 6. So 7 times 6. G of 1 and f prime of 1, that's 1 and 3. Okay, that worked out pretty easily. Okay, and then we're going to be subtracting. Now, how do we do this integral? Geez. Well, the beauty of this problem is they told us this piece of information that is crucial. Like, okay, we have some info on f prime. The only thing we know about g prime, and it's a big one, is that g prime is always 2. Great. So that allows me, if that's equal to 2, and we needed that piece of information that I just boxed here in purple, then I'm just integrating 1 to 4 of 2 f prime of x. Okay, so that just becomes 2f of x going from 1 to 4. So this is just 42 minus 3 minus 2 times, and then f of 4 minus f of 1. Okay, and that should be, again, so we integrate f prime to get f, so we use the FTC. But again, we have those values at the table. This is just 39 minus 2 times f of 4 minus f of 1 is 0 minus 2. So this just becomes 39 plus 4, or 43. What a beautiful problem. So really exciting. Got to use fundamental theorem. Be careful there. So that's how you do a definite integral. You use the same formula. We just got to plug in the bounds on the UV and then plug in the integral as well. Okay, thanks for watching and bring me some questions in class.